For our next game, we will be creating a maze game. Within this game, a player will have to find a hidden treasure within the maze. If the player makes it to the end of the maze, a coupon can be printed for a free game or prize of your choosing. To begin, let's start by creating our new room. And we will enter in our caption window, rainforest, laser tag. And remember, this will be the name that will appear in the top left of the window. And we'll click save. And let's save your game as your last name, maze_alpha. Using the knowledge earned before, we will create a multitude of sprites that will include all of the images that we will need for this game. The following sprites will include the videos shown in the resource tree. I have now entered in all the sprites and the images that will be found in this game. Carefully search for each icon as you go through. The sprite doors will be under the maze platform doors PNG. Sprite down will be under in the same folder, Explorer down strip 8. The gem is under gem blue sparkle strip 32. The gold key is key gold sparkle strip 32. Sprite left is Explorer left strip 8. Sprite lock gold is lock gold sparkle strip 32. Sprite right is Explorer right strip 8. Sprite up is Explorer up strip 8. And the wall sprite is wall block. The Explorer scripts are an animation, so make sure you have those correct before you proceed with the next step. With our sprites created, we will go through and create the objects to correspond with our sprites. The first one we will create is an object avatar, which will be our player icon, and we will set this to the sprite for down. It will be visible but not solid. Our object door, and the sprite will be doors. This will be visible and it will be solid. Our next object is object underscore key gold. The sprite will be our gold key. Visible, yes. Solid, no. Object lock gold. Sprite would be the gold lock. Visible, but not solid. Object blue gem. Solid, but not, visible, but not solid. And our last object for now will be the wall. Both visible and solid. The next step will be to create the first level for our room. If you have not already done so, let's name the room level 1 and press OK. You should see level 1 appear on your left hand side, and we're ready to start designing the game. We want to use our wall sprite, making sure we switch with 32 by 32 grid, and we are going to move wall sprite all the way around the perimeter of the game. Now, for these particular games, our avatar will start in one spot. For this case, we will put him in the bottom left-hand corner, and we'll always exit on another space in the top right-hand corner. For designing these games, we're going to clear the exits in the top right-hand corner, where he will exit the room, by clicking twice to remove the block. Our avatar will start down here, and will return up in the left-hand corner somehow. You can now create a room similar to the one I will create, although it does not have to be exact. We will try to keep enough space in between so that our avatar does not get stuck. Here you can see I've created a simple game where our avatar will start in the bottom left-hand corner and end in the top right. When you have the first level roughly sketched out the way I do, press save your game. We will now begin to set the programming for the rest of this game. A lot of this programming has already been pre-programmed, so you will see that many of the objects that I have you will not have on your screen. No worries, we will get there eventually. Let's start by programming our avatar. The motion for our avatar is very simple. The arrow left, up, right, and down will all move the avatar at a speed of 10 in whatever direction is that the arrow is facing. Create these 4 key press events, making sure that they correspond to the correct direction and the proper speed. When you have finished programming the 4 press events, let's program a collision event with the wall that will stop the motion and set it to 0 so that the avatar will stop moving when it comes in contact with the wall. That will set our player motion to move on command. Now you see the release left, right, up, and down is that if a button is released, the avatar will stop. We don't actually need all 4 of these. What we can do is, instead of creating release events for 4 keystrokes, we can set one event that if any key is released, we will trigger the avatar to stop moving altogether. You should now have the left press, right, up, and down set 10 in the specified direction. Release any key stops our motion, and we have a wall collision also stops the motion. Save your game. If you have not yet done so, place an example of your avatar in your room and let's test to see his motion. As you move your arrows up, down, left, and right, he should move accordingly and stop when you let go of the keystroke. You'll notice that in some instances he will not fit through the blocks, so we have to shrink down the size of our avatar. To do this, we need to go up to our sprites and work our way down from the very top avatar left. We're going to select it, and we're going to edit the sprite. In edit, we want to scale all of our images, and we're going to scale them down to 90%. We'll do this with all of our avatars and check to see that he can now pass through those individual openings. And finally, the last main avatar. Let's now go back and check to make sure he fits through. You can see we have a smaller size avatar that should be able to fit through, but we're just underneath. Let's scale him down one more time. This time we'll scale it down to 80%. Okay, let's save those back up and see if we can now fit through the openings. Notice our avatar is much smaller, but can still whisk away and get through any openings in our game that you have created on your board. Now, one thing you may have noticed about your avatar and mine is that your avatar did not always look like it moved properly. It looked like when it was walking down the screen, no matter which direction you moved it, right, left, up, or down. In this section, we will set the avatar so that it is displaying a separate walking image for each of the directions that can possibly go in. What we're going to do is we're going to open the Object Properties window for the avatar, and we want to select the event for the left keystroke which you've just created. In this instance, when the left key is pressed, we have already selected move in a direction, but we also would like to change the sprite, which can be found under the main one menu. Change the sprite to the left sprite, which is a separate image, making sure your sub image is 0 and your speed is 1. Change the remaining up, down, left, and right keys to the corresponding new sprites to change into. If you hit OK and test save your game, you should now see the avatar moving around as you did mine when he was switching directions. Next, you probably noticed that the avatar still appeared to be running even when you stopped him. To correct this, we will take the avatar, cut out some of his sub-images to just create a stopped look. To do so, you want to go and duplicate your down avatar. In this sense, I already have, mine is named as avatar, and I'm going to duplicate it. I will name this as sprite stopped. I'm going to go into the edit frame, select the second image, and cut it out to the clipboard. I will then delete the remaining images and repaste the single image of the sprite walking down. Checkbox to close, close again, and let's reopen the avatar box, and when any key is released, we will have it show the new stop sprite. Go back and check your game. With our primary game level created, we're going to want to create a second and third level where the avatar will morph to when he exits the screen. We want him to exit the screen and appear in the same place on a different screen. To make this happen, we're going to go to our level 1, which I've already named. I'm going to duplicate it and name this level as level 5. Level 2, I'm sorry. I will keep all of the border, but I will erase the inside of the room. This is essentially clearing the level for the next board. I will also do is create an exit point for my sprite, which I will put in this corner this time. Click to save the room, and let's duplicate an additional room for level 3. This time I will change the exit spot once again. I will delete and fill in my objects here and figure out where you want your goal for this game. Remember, on this from the second to third level, you will be appearing down here in the right top, in the bottom right hand corner, and exiting the top left. After reviewing and building the alpha game build from the first part of this video, we have now determined that we're going to improve the game by adding more features such as doors that need to be exploded to be open, locks, keys, and enemies guarding different objectives. To start, let's open the maze game and save a copy as laser tag, last name, maze, beta, or something to distinguish it from the last game you created. We will need to create another series of sprites for this game. The sprites are going to be located in your maze platform game and will be as follows. Sprite, detonator, down, loaded from the maze platform game. And the image file will be on. Press OK. Sprite underscore detonator up. Which will be off. Sprite underscore diamond. Which will be the sparkle strip. Diamond sparkle strip. Here, diamond sparkle strip 32. Sprite underscore dynamite pack. It should be under dynamite pack. Sprite underscore dynamite stick. Sprite explosion, explosion strip 7. And Sprite underscore spider. Which is the spider down strip 8. Okay, now we have our sprites. You can stop here and save your game. With all the following sprites created, create an object for each one of your new sprites. Detonator down through spider. Make every one of them, all objects, will be solid and visible. Now that you've created all your objects, make sure you went back and double checked. Make sure they were all solid and visible, and that each sprite that we created now has an object in the object window. To make this game more challenging, we're going to add barriers. Barriers are objects that block pathways. The player must either destroy the barriers or figure out some other way to get around them. We're going to open up the room properties box for level 1, maximizing my screen. We want to place instances of the door objects to block the exits to the maze, to place them on top of the exit objects already in place. uncheck the delete underlying checkbox. It is important to keep the exit objects because they contain the programming for moving room to room. Now that we're designing another stage of the game, I'm going to delete my avatar, and I'm going to place him back away from the exit of the door. I'll actually put him back to where we start at. Since we're not going to place our new doors on top of these avatars, we're going to keep them there. We're going to keep delete underlying checked. We're going to take our doors and we're going to add them in front of the exit and place my wall objects around it so that I must get through the doors to get to the exits. Also make sure at this point that your door is also visible. Let's now add a collision event with the doors that if the avatar collides with the doors, then the avatar stops movement. We'll open up our door object and we'll create a collision event with the avatar, which will result in stop motion. And press OK. In other places in drawing, let's place a couple of lock objects in the path of our explorer as well. Double check to make sure the locks are solid. After adding a couple locks into position, let's now move our avatar so that we can make sure that it stops at both the doors and the locks. You'll notice here that we can in fact do get stopped by the lock. As well as the doors. Okay, let's come back, click and save your work. Now, to allow the player to pass through each barrier, a passage key must be placed within the game. The passage key does not need to be an actual key. It can be anything used to eliminate the barriers. You will program 2 different passage keys to allow the player to get through the doors and locks. In the level 1 room, we will place an instance of a gold key in a location where the player can access it before reaching the barrier. In this case, with our avatar start position over here, I'm going to place my key in this position over here. Next, we are going to open up the avatar objects window and program it that if the key if a key is if the avatar is to collide with the key, then destroy the key and destroy the locks. Since the lock barriers will be destroyed, the player will be able to get past the barrier. So if the event is added with a collision with a key, then we will destroy the instance of an object of the locks. Press OK. Let's save and compile your game. You can see that the barriers went away, but our key still remained. We need to add the last bit of programming that also destroys the instance, but also destroys itself. That should take care of destroying the key and unlocking the barriers. Another way to clear the barriers is to blow them up, which is way more fun. The explorer happens to be a demolition expert and gets to use dynamite to blow up the doors and other objects. Note, the dynamite is also considered a passage key. You will do some advanced programming in a bit. Let's first get the basics done right. In the level 1 room, place an instance of the dynamite pack somewhere in the room between the starting position and the doors. Open my level, somewhere between starting key and the doors. I'll select a dynamite pack right before you get to the main stretch of the doors. Next, let's place the detonator up object in a place between the dynamite pack and the door. This should be a place where it will shield the avatar from any blast like from behind a door. Dynamite stick up, and we'll put this over here behind this wall. To begin our programming, we will be opening up the object properties box for the object avatar. We will program the logic statement that if the player presses the spacebar, then create an instance of the object dynamite stick at 16, -16 relative to the player. This will place the stick of dynamite just above the avatar's head. Let's open up our avatar. Let's add an event for pressing our spacebar. Pressing our spacebar, and we are going to drag to create an instance from the main button and drop in the actions column. In the create instance box, we're going to click self to apply to the avatar, and the object text box, we will select dynamite stick object from the shortcut menu. Now enter 16 in the X and 16 in the Y for where that stick will be created, and we want to make this relative to the avatar so it appears just above his head like we mentioned. Press OK, press OK, and let's save our changes. Now we will program the detonator so when the player pushes down the handle, the dynamite stick explodes. The logic statement is this: if the avatar collides with the detonator object, then change the object detonator object to the object down object, the object detonator down, and create an instance of an explosion and destroy the dynamite stick. Okay, one thing at a time. Let's clear our backgrounds. Let's open up the object properties for the detonator stick up. We're going to add a collision event with the avatar. Even though the detonator is not the object that will be moving, the collision event still exists between the detonator and the avatar. There are many actions that need to happen all at once, so we will begin a block of code with our startup block. We will add an action that creates an instance of the detonator object at 0, 0 relative to the detonator up object. So if the collision is made, we'll add a create instance of the detonator object at 0, 0 relative to the detonator up. Then we need to change this to detonator down at 0, 0, and we should be good to go. Last, we're going to check relative so that the instance is created directly over the top of the detonator down, making the avatar, when he runs into the detonator, changes to a detonator stick as the first part of our program. Next, after the collision, we also want to destroy the detonator itself, so we will apply the detonator up. And now we will create a creation event to create an instance of an explosion object relative to the same place relative to the dynamite stick. We have to change the applies to object of the dynamite stick so that the explosion will appear where the dynamite stick already is. The object we will create will be an explosion, and it will be relative. Now let's add an action that destroys the dynamite stick. And press OK. Last, let's drag the block of code from the control tab into the actions figure, into the action screen. So your code has four steps to execute when we press the detonator. Let's press OK, and let's compile our game. To test, we want to see if we can walk up to the doors, press the space bar to place a stick of dynamite. After placing the stick of dynamite, run to the detonator to see if it will be destroyed. This will determine if the programming we created is correct. Now, in this instance, you can see that as we intersected with the key, our locks disappeared. We'll go back and debug this. The problem here is that I am colliding with the key and destroying the lock is what you want. Then we also are destroying ourselves. In this instance, I'm going to destroy the other object, which will be the key. Throw our little man through. And we are going to destroy the key, destroy the locks, and make our way around. Let's continue past the detonator, making sure not to press the detonator too soon. Now we should be able to walk around right up through the bundles of dynamite, walk over to the doors, and place a dynamite stick by pressing the space bar. Now we'll go around back to the detonator, collide with it. It should move down and explode the dynamite. If you have this result, great. If not, let's go back and troubleshoot. Looks like we're okay here. To make the doors blow up and allow the avatar to pass through, program needs to be added to the explosion object. This will also correct the problem of the explosion repeating. Let's open up the object properties dialog box for the explosion and program this logic statement. If the explosion collides with the door, then destroy the doors. Note this is an example where you may want to use the other setting because using the object setting will destroy all of the doors. So we'll add a collision event with the door to destroy the instance of the other, so it destroys the other door and not all the objects that are in the maze. The other part of the statement will be to add the event that if the animation ends, we will destroy the instance of itself. Save and test your game to see if it plays. If everything checks out so far, you probably noticed that as you play the game, you only get one chance to activate the detonator. After you activate it, it's stuck down. If you put the dynamite in the wrong place, you can place more dynamite, but you have no way to set it off. There needs to be a way for the player to reset the detonator. You will program the game so that when the player presses the enter key, the detonator will be reset to the up position, ready to explode more dynamite. We are going to program the file logic statement. If the player presses the enter key, then destroy the detonator down object and create an instance of the detonator up object at 0, 0 relative to the detonator down object. Program this block of code. We will start by opening up the detonator down, and we will start by creating an action of an enter key press, which will simulate the reset. We need to execute a block of code at the same time, so the block of code will start, and the first thing we will do is to destroy the detonator down object. So we will be destroying itself, And next, we will instantaneously, or in the same block of code, which is why we're in our block, we will be creating an object. Create the object of the detonator up relative to where the down detonator is, and press OK. Next, test to see that you can destroy the dynamite sticks. Place a new stick, reset the detonator, and destroy the dynamite stick. Did your game work properly? If so, you should be able to reset your sticks. Place sticks wherever you need to. Collide, reset, and reset it. If you're good to go, let's exit out and save your work. Now that we have dynamite in the game, things are going much more interactive. But the dynamite is automatically available to the player. It is too easy. To increase the challenge, we will program the game so that the player can only carry one stick of dynamite at a time. Variables will be used to achieve this challenge. A variable is a programmable item holding a temporary value such as a number or text that can vary or change. Remember that pack of dynamite you placed earlier? The player will pick up a single stick of dynamite each time the avatar touches the dynamite pack. Open the Object Properties dialog box for the Object Dynamite pack. To achieve this, we'll open up our Dynamite Object window. We're going to add a creation event, and we're going to use a set variable from our Control tab. Set variable and drop it into the Actions window. Make sure the Self Radio button is selected, and the variable, be very careful how you name it, as we will use the exact same name variable later on. So variable is one stick. 0 value in the text box. Press OK to save the action. This sets the number of dynamite sticks the player has to 0. The player will begin with no dynamite and will need to pick up one stick at a time. The avatar needs to be programmed to pick up a stick of dynamite. Let's add a collision event with the avatar. Even though the dynamite pack will not be moving, a collision event with the avatar occurs when it runs into the dynamite pack. We will then drag our set variable, and we will create the same variable spelt exactly the same as we did before. We will create a value of 1 and press OK. This allows the player to pick up one stick of dynamite when the avatar touches the dynamite pack. Now you will need to reprogram how the player can place the sticks of dynamite. Here the computer needs to check to see if the avatar is currently carrying a stick of dynamite. So if it is, the stick of dynamite can be placed when the spacebar is pressed. If the avatar is not carrying a stick of dynamite, nothing happens when the space bar is pressed. Let's click OK to save our action. We'll start by adding a key press event of the spacebar. We will then drag our test variable from our control button, from our control tab, into the action menu. We will make sure the self radio button is selected. Our variable we will enter is the variable we've been using. Spelled exactly as it was before. And let's enter a value of 1 in the box. Make sure the operation is equal to, and press OK. In earlier lessons, we have learned how qualifiers work. This test variable is a qualifier for the rest of the actions. In this case, when the spacebar is pressed and the variable is equal to 1 as a result of the avatar moving over the dynamite pack, then it will execute the next code in response. That code will be a block, so we will grab our start of the block code over as the beginning of our sequence. We will then create an instance from the main tab and drop it into the column. In this instance, we want to program an action such that the object of dynamite stick is created at 16 minus 16 relative to the avatar object. So this applies to the avatar when the object dynamite stick will be created relative to 16, 16. So as the beginning of this code, the avatar will have a stick placed at 16, 16 relative to his position. Press OK. We'll then go back and take our control and set the variable that we've created one stick to a value of 0 as the dynamite has been placed, and therefore we have no more instances. We'll press 0. That will set our variable back to 0, and we can then end this particular block of code. Let's press save and test our work. To add more difficulty to our game, we will add enemy movement throughout our levels. Let's open up our level 1, where you should see your avatar as well as all the other objects that you placed to create the room. And let's place a spider object somewhere between the dynamite pack and the detonator. Now in this case, since there's not a lot of room to wiggle around here, I'm going to slightly edit my board to make it a little easier to work with. We'll put the detonator back over here, and we'll move the dynamite as well. In between, we'll place our spider. Next, we will set a simple path for the spider to follow. Remember, the path was explained a bit earlier. Use the name path spider for path spider for the particular path. Use your cursor and coordinates to display to determine the location of the spider. Then draw the path from the current location to another location so the spider will cross where the player must travel. The path you may create may be different from what it is shown in my example if you decide to place your spider in a more difficult spot to reach. I'm going to start by moving my spider up just a little bit over to here, and I will get my coordinate, and as you can see here, the coordinate in my box down here is x 352 and y of 320. Let's go up to our paths and create a new path. Calling this path spider. And you notice you will see your grid down here changing. So from where my spider is now, which is 352 on the x-axis, let's change our grid size first. 352 on the x-axis and 320 on the y. So here's the starting point for my spider. I'll click here as a starting point or change it over here, 352 and 320. That will be the starting point for my spider, and I will then add an ending point somewhere below it around here so that the spider will move along this path. With our path completed, let's close it out. Let's now go back and open up our spider object menu, where we'll create the event for him to move along the path. We must first add our creation event so that the spider is created, and then we will drag the set path button from the move tab into our actions window. We will enter a speed of 2, set the path we defined for the spider. Now at the end of the path, we want the spider to reverse and go back up the path he came down. And in the relative checkbox, we want to select absolute from the shortcut menu. This is because you need the absolute coordinates to stop where the spider is. Press OK. And let's test our game. Now while testing my game, you can see my spider is moving up and down. However, my coordinates are just a little bit off, so we are going to take our coordinate path, and move it slightly up so that it fits within the parameters. I'm now going to move my parameters up and check the game. And you can see at the low end he's stopping, the high end he's just going a little too big. Drag the set lives to the actions and enter -1 in the column relative to the score you have. Next, once we lose the life, we want to drag the jump to start button from the move tab and drop into actions. This will take our avatar and jump back to the respawning position at the beginning of the level. Click OK. Be sure that in the object button you have clicked the object for the radio button. Then click the text box that appears and select the avatar from the shortcut menu. This will return the player to the starting position. Now we will drag our test lives into our actions menu. Our test lives will be set to 0. We'll press OK. Now find your end game scenario so that every time you test the spider you lose 1 life. If your lives are equal to 0, the game will then end. Carefully looking at the code, you realize that this collision event happens with the avatar. Instead of having this collision event with the avatar and the spider, let's open up the spider's avatar and create a collision event with the avatar. Now we should be able to copy and paste the code and paste it in so that the collision event comes underneath the spider, and we can delete the excess code. To set the total of lives for the game, we're going to open up our wall event, and we'll create a new event which is going to be setting our lives to 3, unchecked. This will give us 3 lives as the game starts. Play your game, make sure you run to the spider and test your lives when it respawns.